Hello everyone, welcome back to my channel. Hope all of you are doing well. Today I am going to discuss about techniques and methods by which we can draw organic molecules. This is going to be an introductory lecture by which I am going to make a platform. Okay, so let's begin. Here I am going to show you some very amusing organic molecules and their structures. First of all, as you can see, two dancers over here having some good moment with each other. There is a series of organic molecules whose structural formula resemble human forms. In the year of 2003, James Tour designed and synthesized these compounds and they are known as nanoproteins. Now look at this. What a huge molecule, na? This is Palitoxin, one of the most toxic compounds ever known, requiring only about 0.15 microgram per kg for death by injection. And this is Brevatoxin B. It actually causes red tides around the coasts of the Gulf of Mexico. Now let's move on to the next slide. For drawing an organic molecule, at first you have to identify the hydrocarbon frameworks. As we all know, most of the organic molecules contain carbon and hydrogen. It is important to recognize the framework very well. It may be made up of chains as well as rings of carbon atoms, and it acts as a support for the functional groups. Here I have drawn a chain, a simple one, a ring and a chain which is branched. You can see very well I have used different colors to distinguish between carbon atoms, CC bond, and hydrogen atoms, CH bonds. Now the question which is arising from this slide is, what is functional group? Let's see. Functional groups actually determine the way the molecule works both chemically and biologically. There are several functional groups found in different organic molecules. Some of them are here. Another point is that a particular group makes a series of molecules itself known as homologous series. Now look at this table. At first you can see here is CC double bond. Formula is given here and the name of the homologous series is alkene and one example is ethene. Okay. Next one is CC triple bond. Name of the homologous series is alkyne and one example of it is ethyne, or you may also say it as acetylene. Next one is the hydroxyl group. Formula is OH. Name of the homologous series is alcohol when it is attached with alkyl. The name of it will be phenol when it will be attached with aryl groups. The example of one alcohol is methanol, and phenol is there is a hydroxyl group in phenol which is attached with the benzene ring, that is the aryl ring. Next one is ether. Okay, homologous series name is also ether. One example of it is dimethyl ether. Now aldehydic or formyl group, which is represented as CHO. Name of the homologous series is aldehyde and one example is acetaldehyde, which has the formula CH3CHO. Next is ketonic group. Name of the homologous series is ketone. One example is acetone, that is CH3COCH3. Next it is carboxyl group. Its formula is COOH. Name of the homologous series is carboxylic acid and one example is acetic acid, CH3COOH. Next one is alkoxycarbonyl, or better ester. Formula is COOR. You know R is the alkyl group here. Name of the homologous series is ester. One example of it is ethyl acetate, CH3COOC2H5. Next is halocarbonyl. formula is COX. Name of the homologous series is acid halide. Okay, X is halide here. It may be fluoride, chloride, bromide or iodide. Okay. One example of it is acetyl chloride, that is CH3COCl. And the last one in this slide is amido. It has the formula CONH2. Name of the homologous series is acid amide. One example is acetamide, CH3CONH2. Next, sulfonic acid. Formula SO3H. Name of the homologous series is sulfonic acid. One example is benzene sulfonic acid, C6H5SO3H. Next one is amino. It has a formula NH2. Name of the homologous series is primary amine. One example is methanamine, or you may also say methylamine, that is CH3NH2. Next, imino. The homologous series name is secondary amine. One example is dimethylamine, that is CH3(2NH). Next one is tertiary nitrogen atom. Okay, the name of the homologous series is going to be tertiary amine. One example is triethylamine. Oh, there is a mistake here, that will be trimethylamine, and the structure will be CH3(3N). Okay, the next one is cyano group. Formula is CN. Name of the homologous series is cyanide or nitrile. One example is methyl cyanide, CH3CN. Next, nitro group. Formula is NO2. Name of the homologous series is nitro compounds. One example is nitromethane, CH3NO2. Next is halo group. Formula is X. It may be fluorine, chlorine, bromine or iodine. Name of the homologous series is halide. One example is methyl chloride, CH3Cl. Okay, now you see amino acids are made up of amino group as well as carboxylic acid group. They are the building blocks of protein molecules. Okay, so amino acids are those where both the functional groups amino as well as carboxylic acid is present. Okay, here are the structures of some amino acids. The first one is of glycine, then tryptophan, then serine, then glutamic acid, and the last one is lysine. You can see in glycine the structure is NH2CH2COOH. In tryptophan you can see there is ring. Okay, in serine, apart from NH2 and COOH group, you can also see, or you can also find a hydroxyl group over here, that is the OH group. Glutamic acid, you can see there is an extra COOH group, so it is known as acidic amino acid. And in lysine you can see an extra NH2 group, so this amino acid lysine is known as basic amino acid. So that's it for today for drawing an organic molecule, which actually we will do in the next lecture. Okay, so for drawing an organic molecule you need to be realistic and scientific. You need to be economical. You need to be very clear what you are drawing. And the last of all, you don't need to be Pablo Picasso or our very own Nandolal Bose to draw organic molecules. So that's it for today. Hope you like this. If you like this, please share and subscribe my channel and hit the bell icon. Thank you.